Good evening, students. Today I will continue with the differential equation of SHM. So in the previous video I have completed what is the SHM, what is its property, how the velocity, the acceleration is defined in the SHM, what is the general equation of SHM. So today I will continue with the differential equation of SHM. So I think what is differential form or what is differentiation already you know, but still I am giving a brief description about differentiation before going to the SHM part. Okay, so basically the thing is that what is differentiation? It is a part of calculus. It is basically depends or it works or it validates on the continuous platform. What is continuous platform? Basically there are two types of problem which we are dealing. First one is the discrete problem, another is the continuous problem. Up to this, whatever you have learnt up to class 10 as well as class 11 also, you have dealt with the discrete form, that is x equal to 2 means 2, right? But if I say x equal to 1.99999, it is also near about to 2. If I say x equal to 1.000009, it is near about to 1, right? So basically it is the continuous form. In real there is not such a exact value that is called 2 or 3. There is 2 point something or 3 point something. So for the research work or for more accurate measurements, we should require this specification, right? So to find out or to deal with that specification, we need the calculus. Okay, so for calculus there are two operations. First one is the differentiation, second one is integration. Okay, integration you will learn in class 12. Now differentiation is there in your syllabus. So the first thing is that differentiation is basically DDT operator which works on a function. Okay. Now the thing is that how differentiation works. Basically differentiation means the difference. Okay, and integration means the addition. So there are basic two operations, integration and differentiation, which is nothing but summation or sum or addition and difference, that is minus, subtraction, but it is in the continuous domain, not in the discrete domain, right? So let us understand by this graph. Suppose this is a curve. Okay, now if I take 2 points A and B here, how you will find the difference? That is basically x2 and x1. So x2 minus x1, that is the difference. Clear? Now if I make these again so small, so it is not possible physically to find out the difference. That's why we use this operator d dx. Okay, clear? Now d dx is the operator which works based on a function fx. So fx is a function which is being operated by this d dx operator. Okay, so now there are some formula that how we can operate this. Suppose if fx equals to some polynomials, suppose x cube plus x square plus 3x. So this is the polynomial. Okay, so if I do the operation d dx, so what will be the result? The result is this x cube, d dx of x cube. You can write like this, d dx of x cube like this. Okay. So, afterward what will be the result? The result will be basically d dx of x cube, that is 3x square, that is 2x, the next one will be 3. Now, you will ask how, ma'am, it will happen basically. So, there is a formula. What is this formula? The formula is saying that if d dx is being operated with x to the power n, then the result will be n into x to the power n minus 1. Now, taking the similarity between this d dx of x cube, right? So, here whatever the n is here, 3 is here, same thing. Now, n, so 3 x to the power n minus 1, that is 3 minus 1, which is nothing result 3x square. So, that is 3x square. Same thing is happening for x square as well as for 3x also. 3 is basically the constant, so it does not being operated by the dx operator. So, only x is being operated. Hopefully, it is clear to all how differentiation will work or is working. Those who know what is differentiation, I think it is pretty much easier for them to understand, and those who are new in this part, I think a slight idea, very slight idea should be grown. So, now coming to the differential form of the SHM. Suppose a body of mass m is initially at rest in its mean position, and it is being slightly disturbed by applying an external force. So, a restoring force will develop immediately, which tends to bring the body back to its mean position. Suppose a body is here, a small amount of force is being acted to this. Now, it is being displaced, and again a restoring force is acting here, which makes the body to come here. Okay, clear? According to the Hooke's law, basically the force F, that is the restoring force F, should be the some function of distance of a particle from its mean position. Let the distance be y. So, that is basically F proportional to y, and if I write F equals to minus ky, what is k? K is the proportionality constant, and y, this is minus, in which we have applied the force, the displacement is in the opposite direction. That's why it is in this negative sign is arising. Okay. Now, what is velocity? Already velocity you know, that is dy dt, and for acceleration it is basically defined as d2y dt squared, that is the double derivative according to the Newton's law. So, we all know that F equals to ma. Already for a, that is basically d2x by dt squared, right? Now, according to Hooke's law, what we have learnt? We have learnt that F equals to minus ky. So, what is F? F is nothing but my m into d2x dt squared, that should be equals to minus ky, or d2x dt square equals to that is equals to k by m into y. Okay. So basically this is nothing but the constant and this is the acceleration. Therefore, acceleration is directly proportional to y, that is displacement, right? Now, if I write k by m as the omega square, so what will be the result? The result will be basically d2, sorry, here not x, here it will be y, as I have considered is y. So d2y dt square, that is equals to minus omega square x. So therefore d2y dt square is plus omega square y, that is equals to 0. So this is the differential form of, this is the differential form of our SHM. And if we differentiate this, then what will be the solution of? That's the solution y will be nothing but the same thing, that is equal to a sin omega t plus phi. Okay. Hopefully it is clear to all. Now, to check the actual nature of the motion of this equation on mathematical ground, we need to solve the differential equation for y as a function of time t. Okay. So let us solve this part. So the equation is d2y by dt square plus omega square x, that omega square y, that is equals to 0. So on multiplying dy dt both side, 2 into dy dt, okay. That is equals to 0. Now, if we integrate this, so what will be the result? The result will be basically dy dt square plus omega square y square, that is equal to c1. c1 is the constant of integration and which can be obtained by applying the boundary. So we know that the SHM when displacement y equals to a, it is the condition when velocity equals to 0. Velocity 0 means dy dt equals to 0, right? So in this condition, what will be this c1? The c1 will be 0 plus omega square a square, that is equal to c1, or c1 equals to omega square a square. So now the equation becomes dy dt whole square plus omega square y square, that is equal to omega square a square. Okay. So dy dt is nothing but root over of omega is being taken out, a square minus y square. Or what is dy dt? Dy dt is nothing but the velocity. So velocity is omega into root over of a square minus y square. So this is the velocity of the simple harmonic motion. Okay. So again, from this point, if we do that integration again, a square minus y square, that is equals to omega of dt. So the integration will be results sine inverse of y by a, that is equals to omega t plus c2. c2 is again the integration constant, and from here we can write it that y by a equals to sine of omega t plus c2, and if we apply the boundary condition, this c2 is nothing but the phi. c2 will be the phi, so y will be a into sine of omega t plus phi. So it is the original SHM which we got previously. So therefore, from the differential form again we can capable to find out the displacement for the particle present performing SHM. Okay. Hopefully it is clear to all. In the next part, I will discuss the graphical representation of the displacement, velocity and acceleration of SHM, and later on total energy of particle SHM and all these things. Okay. Thank you.